Well, welcome back. So we're going to be factoring trinomials in the form of x squared plus bx plus c. And I'm just going to mess around with math. We're going to be factoring and multiplying our inverses processes often. We can use this to factor a trinomial. For example, x plus 2 times x plus 10, this is going to be equal to x squared plus 10x plus 2x plus 20. So therefore, we can conclude that x squared plus 12x plus 20 can be factored in the form x plus 2, x plus 10. Now, maybe, if you don't really like my arguments so far, I won't take it too personally. What I'm going to do, though, is I'm going to factor out x from this term. So, if I do that, what I can see is that this is 10 plus 2. So, what two numbers add to 12 but multiplied to 20 is 10 plus 2. And 10 plus 2 multiplied to 20. This is surely no coincidence. So to determine the factors of a trinomial, first we need to play this game. We need to determine two numbers whose sum is b, but whose product is c. In other words, I would say we're looking for two numbers whose sum is b, but whose product is c. All right, I'm hoping this makes sense. These numbers are the constant terms of the binomial factors, each of which has x as its first term. I will be relying on the strength that you are going to consider this to be case 1. And case 1 is that when we have a trinomial in which the coefficient in front of the x squared is 1. Really important. Example 1. Is this case 1? And in fact, it is. The number in front of the x squared is 1, although we don't write it. So right now, what we need to do is we need to determine which numbers have a product of 15, but whose sum is 8. Tell me two numbers that multiply to 15 but add to 8. So we open up our brackets, a binomial. X's go first. I'm hoping that you're saying 3 and 5. Right? Those two numbers multiply to 15 but add to 8. If you are having troubles with this, perhaps you're going to break up 15 into its factors. 15 can be equal to 1 times 15. It can be equal to 3 times 5. It can be equal to negative 1 times negative 15. It can be equal to negative 3 times negative 5. Now, you tell me which one of these pairs add to 8? Those ones. And if you notice, those are the two numbers. All right. B. I love this stuff. Now, you tell me what two numbers multiply, or whose product is 7, but sum to 8. Now, you and I both know that two numbers multiplied together, when they multiply and they're positive, two numbers are positive. Sorry, let me start that again. When two numbers have a product that's positive, that implies that both those numbers are positive or both those numbers are negative. So now that you know that both those numbers are positive or negative, that when we add them together, that those two numbers add to something negative. So that implies that those two numbers must both be negative. Anyways, I'm saying this to shorten up your work. So allow me to do some legwork. I'm going to take 7. I'm going to write down all the combinations that multiply to 7. 1 times 7, but don't forget, -1 times -7. Which two pairs, or which pair of numbers, add to -8? There we are. So if I'm factoring this, I would write it as, okay? Also, you may want to write it like this. It's your choosing. It doesn't matter which way you write it. Both of them are the same. All right, good times. You tell me what two numbers multiply to -8, but add to -2. So perhaps I'm going to start off with -8. And I'm going to work systematically here. I'm going to use my factor rules. So I know that 1 times 1 times -8. Now, my next positive factor after 1 is 2. 2 times -4. 3 is not a factor, but 4 is. 4 times -2. -8. So 8 times -1. I could say, then I'm going to switch negative. -1 times 8, but that's already been included. Right? -2 times 4 has already been included. -4 times 2 is also included. -8 times 1. So tell me which combinations multiply to -8 but add to -2. That's the combination. So let me put it to you this way. Don't look at the paper. What two numbers multiply to -8 but add to -2? Boom. You may have it in your brain. All right, I'm going to pick up the pace here. There's a lot to do. All right, D. D. Is this case 1? Yes. The coefficient in front of the y squared is 1. Awesome. I love this game. What two numbers multiply to positive 35 but add to -12? Great question. By the way, I'm just going to open up my brackets. There we have it. I know that this is going to be y times y because this variable is y squared. So I'm just going to go out on a limb. -5, -7. If two numbers multiply to a positive numbers, you know both those numbers are positive or both of them are negative. Now, having said that, if they add to a negative number, well, and both of them have to be positive or both of them have to be negative, you can conclude that both of them are negative. All right, a lot less chit-chat. I'm going to move forward very quickly now. W squared plus 7w minus 18. If I'm factoring, I'm looking for two numbers whose product is -18, but whose sum is -7, or sorry, whose sum is +7. Now, if I'm doing that, I know that is going to be w minus 2 times w plus 9. Maybe you want to press pause for the additional ones and just practice this out. Write out my polynomials. What two numbers multiply to positive 16 but add to -10? Now this one might be a little bit tricky. It's actually tricky for me. Oh, wait a second, I got it. -8, -2. And if you want, you can multiply this out and check, right? M squared minus 2m minus 8m and then plus 16. And there we have it. Oh, gross. I don't like this. Why don't I just reorganize it? You know, the reason why I don't like it is because it's in the form that I don't like. So I'm going to choose to write it as 8x squared plus 14x plus 24. So I'm looking for there. Now I understand. Ah, yeah. So I'm put into a place of success, right? So what two numbers multiply to 24, but add to 14. 12 and 2. Now remember, it doesn't matter which order of factors you write it. Gross. Ugh. Anyways, let me factor this. Now, how do I, okay, right off the hop, what would I do? I would just write it in descending order the way we write polynomials. And if you remember, it's the highest degree to the left and then decreasing order of degree as we go to the right. So k squared plus 7k minus 30. Whew. All right, let's see. Mental math. Don't fail me now. No idea. Okay, so I know that those two numbers, I'm just going to write negative 30. And I'm just going to factor negative 30. And by the way, the sum is positive 7. So I know the larger number is going to be positive. So, nope. 15, my next negative 30 would be 10. Oh, there it is. Those are two numbers that multiply to negative 30, but add to positive 7. So really, this is all good, except for this last one. Is this a special case? It is a special case, but this is also case 1. What is the coefficient? Coefficient in front of p squared is 1. You know, what is missing? We're missing a term of p. I could write it as this, couldn't I? The reason, if I add 0p to this, in other words 0, it's still the same thing. Now, I need to find two numbers that multiply to negative 4, but add to 0. And we actually took this example before, and that would be negative 2 and 2. Oops. So, right, I open this up. Here we are, negative 2, and my last question having tons of issues with negative 2 and positive 2. And that's it. If you guys